Questo è un podcast offerto da Polytalks.
Hello everybody, we are Simona
Giuseppe.
Ada.
and we are with Juan, Andrea and Alessandro, and today will talk about James Webb telescope and how it is revolutionizing our understandings of the primordial universe.
Hello everybody, thank you for having us.
Hi everyone, thank you.
Hi everyone, thank you for inviting us.
James Webb is also known as the next generation space telescope. And what is a space telescope?
The Webb telescope observes stars in the orbit around Earth, and it is called a next generation because it observes astronomical objects with infrared radiation instead of the spectrum of the light, which is visible for the human eye. Was projected by NASA, partnered with two main agencies, which are European Space Agency and Canadian Space Agency. All the project cost by NASA $10 billion until 2021, but an interesting fact is initially was estimated for $1 billion.
What are the main features of Webb telescope and why it is more powerful than other telescopes?
Okay, so why is different from other telescopes is basically because it gets the infrared radiation of other objects. So mostly other telescopes work in the same wavelength as the human eye. So the observable universe is very limited in that spectrum. Infrared can catch older bodies, older stars that are very obscure and emit mostly infrared light. There is also one thing about the position. The James Webb telescope is located in a Lagrangian point, so it's not orbiting anything. It's just by cancellation of the gravitational forces of the moon, the earth, and the sun, has a stable orbit. But it's a very special point because since it is detecting infrared radiation, it needs to be cooled down below the 50 Kelvin. So it needs to remain in a position where the light of the sun doesn't increase the temperature of the telescope, and the solar shield needs to be always pointing at the sun and also at the light that is reflected by the earth and by the moon. The solar shield is just 5 layers. Every layer is as thick as a human hair. It protects the telescope from 300 Kelvin to 50 Kelvin. So on one side of the solar shield is 300 Kelvin, on the other side it's 50 Kelvin. The other main feature that it has is it's a huge origami puzzle. So it needed to be folded to fit in the Ariane spacecraft that has a diameter of 41 meters. But the shield spans 16 kilometers wide by 21 kilometers length. So it was folded, then shoot to space, and in space it was unfolded. And the last, but not least, thing about the telescope is the number of devices that have to detect the infrared light. So it has a lot of cameras that span in the wavelength of 0.6 micrometers to 6 micrometers, which is actually non-observable for the eye. The things that it detects, it can actually detect some bodies that are outside the Kepler ring, and there are some things over there that are very obscure that only emit infrared light. So the devices that you need that the James Webb telescope has inside in order to detect and to focus the telescope into the right way are simply amazing.
So, what are the goals of the mission, and what are also the future prospects about Webb?
Yes, so as my colleagues have said, James Webb is an infrared telescope. So that means it can investigate better what is the origin of the universe, because the visible light that our eyes can see has been redshifted in this long period of time that has passed. So the oldest object in the universe do not longer emit visible light from our perspective. So The infrared radiation allows us to investigate the older objects of the universe and also to see behind the curtains there are the dust particles in the universe. So the main focus of Webb is investigating the origin of the universe and seeing with better resolution objects which were already observed by Hubble, like nebulas, and because Hubble used the visible light, so it couldn't see past some of the dust surrounding these objects. So overall, investigating with more resolution already observed objects and investigating completely new objects which are the oldest in the universe.
Okay, so somebody say also that Webb pathing the Big Bang theory. Is that really true?
Well, the answer is both yes and no, because as we are seeing the oldest object in the universe, we are still seeing expansion as we expected. So when we propagate back this expansion, we see a contraction, which if you go all the way, it goes into the Big Bang, which is the singularity. At the same time, the Webb telescope is finding very strange objects, like stars that appear older than the age of the universe, and galaxies very structured form a few million years after the Big Bang, which is in contrast with the current theories about the universe formation. So Webb is probably pointing at the fact that the universe is older than we expected, or that our cosmological model is either incomplete or partially wrong. So that's a great opportunity, and is the reason why Webb was developed, to put our theories about the formation of the universe at test and see where we might be wrong and where we might correct our theories. If I may add something, there are some theories that these galaxies that do not make sense are actually dark matter stars. So they are stars that at their core envelop dark matter, which annihilates with itself, produces energy, and then illuminates the surrounding hydrogen and helium. So this might be a very, very interesting opportunity also for particle physics, not also for astrophysics, to investigate the nature of dark matter. If this object prove to be dark matter stars, it could revolutionize physics. And this is one of the best development about the Webb, that with more observation of this object, we can understand more about the origin of the universe and also the origin of matter and dark matter.
Perfect. Thank you so much.
Thank you, Juan, Alessandro, and Andrea, for your time and your precise information. And good evening.
Thank you very much. I hope you enjoyed it. For me, it was a pleasure.
Thank you. It was fun.
Thank you very much. It was a pleasure to be here.
Se questo episodio ti è piaciuto, seguici su Spotify per non perderti le prossime puntate.